about the Poisson's distribution. Poisson's distribution is a limiting case of the binomial distribution under the following condition, like where n is the number of trials is indefinitely large. That means n may be equal to infinity. And the p means it is the constant probability of success for each trial is indefinitely small, that is p may be equals to 0. Okay, so and the total number of trials are very much high and the constant probability of success is very low in Poisson's distribution, and n multiplied by p is equals to m is finite. Okay, so over here m means it is the mean of Poisson's distribution. Okay, thus p is equals to m divided by n, or you can say q is equals to 1 minus m divided by m. Okay, where m is the positive real number and q, to you people know, q is the probability of failure. Okay, now Poisson's distribution occur when there are events which do not occur as outcome of a definite number of trials, unlike that in binomial of an experiment, but which occur at random points at time and space, wherein our interest lies only in the number of occurrences of the event and not in its non-occurrence. Okay, so basically what happens over here is, in a Poisson's distribution, it is the probability distribution that is used to show how many times an event is likely to occur in a specified period of time. Okay, so basically it is a count distribution and we are not concerned with non-occurrence, that is the value of q. We are not at all concerned with the non-occurrence. We are concerned with the occurrence of a particular event. Like we have got few examples, like number of deaths from a disease such as heart attack or cancer or due to snake bite. Okay, so we want a number, like in particular year how many deaths were there. Okay, we don't want that how many people are alive. We don't want that. Okay, we don't want q value. We don't want non occurrence. We just want occurrence. Number of suicides reported in a particular city, a complete figure we want. The number of defective material in a packing manufactured by a good concern. Number of faulty blades in a pack of 100. Okay, number of air accidents in some unit of time. Number of printing mistakes at each page of a book. Okay, so this is, we can calculate using Poisson's distribution, like how many printing mistakes are there. We don't want how many correct wordings are there. We don't want that. We want how many printing mistakes are there. Okay, occurrence. Number of telephone calls received at a particular telephone exchange in some unit of time, or connections to wrong number in a telephone exchange. Number of cars passing a crossing per minute during a busy hours of a day. Okay, so these all are examples of Poisson's distribution. So here we are basically concerned with how many time an event is likely to occur in a specified period of time. Okay, now the probability function of a Poisson's distribution is given by the equation PR is equals to e to the power of minus m multiplied by m to the power of r divided by r factorial. Okay, now over here the value of e is 2.7183 and this is actually base of the natural logarithm. M is mean of Poisson's distribution and it is calculated as m is equals to n multiplied by p. And what is n and p? You people know it very well. N is the total number of trials and p is the probability of success in each trial. Okay, and r also you know, number of success in a particular time period. Okay, so we'll have an example and we'll see how we can use this Poisson's distribution equation. 10% of the paracetamol tablets produced by dry granulation method is defective. find the probability that in a sample of 20 tablets chosen at random, exactly 6 will be defective by using Poisson's distribution. Okay, so here in the question itself it is written that we need to use Poisson's distribution. Okay, so what exactly is this question? We have manufactured paracetamol tablets by dry granulation method. How many tablets are been produced? That entire figure is not given, but it is given that 10% of the tablets are defective. Okay, so what is the probability that, like, in some this paracetamol tablet, if randomly we pick up 20 tablets, how much is the probability that 6 among those 20 tablets are defective? This you want to determine. Okay, now for solution we need to write this Poisson's distribution. Okay, and we'll write all the given values. E value that we know, it is the base of natural logarithm, which is 2.7183. N is the total number of trial, which is, yes, 20, because 20 tablets we are about to take. Next, P is the probability of success. Okay, in this entire thing, how much is the probability of success? Yes, 10%. Means defectiveness is our success in this case. So it is 10%. Okay, so 10% means 0.1. M means M is equals to N multiplied by N, isn't it? Sorry, N multiplied by P. So 20 multiplied by 0.1 is 2. R is the number of success. And what is the success over here? To get 6 defective tablets. Okay, so that is 6. Now you need to keep all these values in the formula, in this equation. So E is 2.713 to the power of minus 2 multiplied by M is 2 to the power of 6 divided by R factorial is 6 factorial, that is 6 into 5 into 4 into 3 into 2 into 1. Okay, now over here you can see 2.7183 to the power of minus 2. For solving this we can take it to the denominator. Okay, next everything is simple. You need to multiply 2.7183 multiplied by 2.7183, isn't it? So you will get the answer. But suppose instead of to the power of 2, if it is to the power of 18, 20, then what you need to do, that I'll show. Okay, for now, as of for now, it is just 2.7183 to the power of 2. It is very simple for calculation. But suppose in examination it comes to the power of 7, 8, 20, 30, anything, then you need to use such kind of way for solving it, like 1 divided by anti-log of 2 multiplied by log of 2.7183. Okay, so log of 2.7183 is 0.434. So 2 multiply, you do it, you will get anti-log of 0.868. 1 divided by 7.38, or you can write it as 0.1355. Okay, so you got the value. 2.7183 to the power of minus 2 is 0.1355 multiplied by 2 to the power of 6 is 64 divided by this entire value. If you calculate, you will get 720. Okay, so just go on calculating it, you will get the answer 0.012, or you can write 1.2%. Okay, so we have got 1.2% of probability to get 6 defective tablet among the randomly selected 20 tablets. Okay, so this was all about our today's video regarding Poisson's distribution. I hope you people found this video helpful. Thank you for watching.